All right, guys. So we're going to start off here today. We are going to kind of keep going with the geometric sequence. We're not going to do series right away. This is our last type of problem that we're going to face here with geometric sequences. So this is a case where they give us two terms, and they're saying the third term is 48 and the sixth term is 3072, and they want us to write a rule for the nth term. Now, they do not give us the first term, and they do not give us r. So this is all stuff we're going to have to find. Now, remember, our equation for finding the rule for the nth term looks like this. Now, like I said, I do have my third term and my sixth term, so I'm going to work with those and see what I can do. So, for my third term, I know it's equal to 48, but that's pretty much the only thing I know about it. So I'm going to say it's still equal to my first term times r, but r is to the n minus 1, and since n is 3, r is going to be to the 3 minus 1. So that's somewhat helpful. And I know that's equal to negative 48. Okay, so let's simplify this down a little bit. So I'm going to say that this turns into a sub 1 r squared is equal to negative 48. All right, not that helpful. Let's try to work with the sixth term and see what happens there. So the sixth term, I'm going to kind of treat it the same way. I don't know what my first term is. I don't know what my r is, but I know it's raised to the n minus 1, so I know it's raised to the 6 minus 1. And I know at the end of the day, it equals 3072. So what I have here is a1 r to the 5th, 3070 is equal to 3072. So what I have here, kind of most fundamental idea of algebra, is I have two equations and two unknowns. These are my two unknowns. These are my two equations. So I can set them equal to I can kind of work with them. I don't want to say set them equal to each other. I can manipulate them and do some substitution and work and see if I can get what those variables are, just like you guys used to do when you solved the x and y equations. So it doesn't really matter which one you use or which one you start with or what you solve for. I tend to like to solve for a sub 1. So I'm going to say I'm going to divide this one by r squared. So I'm going to say a sub 1 is equal to negative 48 over r squared. Now, that's for that equation. That is a little bit helpful, because what this does is it gives me a substitution to put into this equation. So I can say, well, I know what a sub 1 equals. It equals negative 48 over r squared. That's my rule. So I'm going to say negative 48 over r squared is my a sub 1. Then I have r to the 5th, and that's equal to 3072. So I'm going to just clean this up here a little bit. Now, we know from our rules of exponents that when you have things with the same base, these r's, one in the top and one in the bottom, you subtract their exponents. Those are rules of exponents. So what this turns into is negative 48 r cubed, 5 minus 2 to give me 3, and this is equal to 3072. Now that's really kind of nice. And this turns into a problem that I hope that we can do. So we can divide both sides by negative 48. Have your calculator ready. So we have 3072 divided by negative 48. And we get r cubed is equal to negative 64. And I can take the cube root of that. So math, cube root, negative 64. So r is equal to negative 4. So I found my common ratio. That's like a big deal. That's very exciting. So the only thing I have left to do is find what a1 is. I have to find what my first term is. So I'm going to do another substitution back into the thing that I originally substituted with. So I have a rule for a sub 1. It's equal to negative 48 over r squared. And I said r was negative 4, and I'm going to put this in parentheses so I know to do that in my calculator. So I have negative 48 divided by negative 4 squared, negative r squared. And I get my first term to be equal to negative 3. So my rule, because they do want the rule, so we'll put it all together and make the rule. my rule is any term, the nth term, can be represented by negative 3 times negative 4 to the n minus 1. So we got two equations, two unknowns. We did a little substitution, simplified, and then resubstituted to get our final answer. And this, ladies and gentlemen, is the final answer that we want. Okay, I'm going to do another one before you guys kind of attempt it on your own. We do have one for you to attempt on your own, though. So we have the one, I think I have this as a DIY, but I think this is kind of tricky, so I'm going to go through it anyways. So once again, we got the third term and the sixth term. Same idea. We're going to say, I don't know what A1 is. I'm trying to find that. I don't know what R is. I'm going to find that, and I have my rule in mind. So we are going to get two equations. We're going to solve it for two unknowns, and we're going to get the rule. So my third term, they tell me it's equal to negative 32. So I know it's equal to the first term times the rate, which I don't know, to the n minus 1. So just like we did on the previous page. I know this simplifies to a1 times r squared is equal to negative 32. Alright, so I'm kind of done with that side. Then I'm going to use the sixth term and work with that. So I have the sixth term is equal to the first term times the r to the 6 minus 1 n minus 1, and that's equal to negative 2048. We'll clean it up. Alright, now we have our two equations, two unknowns. Like I said, it doesn't matter what you solve for. I like to solve for a sub 1, and I'm going to do that here. So I'm going to divide both sides by r squared, and I'm going to get a sub 1 is equal to negative 32 over r squared. And I'm going to substitute this piece in here. So I have negative 32 over r squared times r to the fifth is negative 2048, or negative 32 r to the fifth over r squared is equal to negative 2048. Same idea. Rules of exponents say that if I have the same base, I subtract the exponent. So I have negative 32 r cubed equal to negative 2048, and I can divide by negative 32. Negative 2048 divided by negative 32. We get 64, so r cubed is equal to 64. And if I take the cube root of that, I get 4. Okay, so that's kind of nice. Now that's r. I've got to get the first term, so I'm going to plug r back into here. So I'm going to take this and shove it back into this equation. So I have negative 32 over 4 squared. So negative 32 divided by 4 squared. I get negative 2 as my first term. This is a1. So I have negative 2 is equal to a1. I have my r is equal to 4. So I want to write my rule for the general nth term. So any term for this sequence of numbers can be represented saying negative 2 as my first term. 4 is my ratio to the n minus 1, and that is your final answer, ladies and gentlemen. Okay, so these next three are some DIYs for you. I gave you one of each, so I'm going to give you the answer, so hopefully you can kind of get what you need to get here. So for this one, they asked for the rule for the nth term, and then the 8th term. This one, same idea, the nth term, and then the 8th term. Now these two are from yesterday, so if you don't know where we just did this, that's because we did this yesterday. And then for the last one is just like the last two problems we did. I will get my rule to be a sub n equal to negative 24 times 1/2 to the n minus 1, and the 8th term I get is negative 0.1875. So hopefully you guys can try those ones out on your own and see that we can get the same thing for all three of them. Obviously this one is the most challenging out of them. So start here and go down the list. Alright, last and final thing we are going to talk about is geometric series. So, the expression formed by adding the terms of a geometric series is called a geometric sequence is called a geometric series. We have a formula for this, just like we have a formula for the arithmetic. There's only one though, so we don't have to worry about two different ones. Finding the sum of the first n terms of a geometric series is denoted by, and we'll use big S, little n, and the rule to find it looks like this. So it's S sub n equal to a sub 1 minus r to the n over 1 minus r. So a little tricky to manipulate, so we're just going to be careful when we plug this in. And just to get us used to seeing summation notation, and kind of having us go through this. Now, what's nice about these problems, and these problems here, and even the ones that you have to do it on your own, that these rules inside these summations already follow this format. It's got some number times another number, and that number is raised to the n minus 1, or in this case the I minus 1 for your index to make sure that they match up. So actually this is really simple because you can just pull this information right from the problem, and you can say that guy right there is my first term, this one right here is my rate, and your n is that number on top. So pretty straightforward plug and chug here. So we're going to say the sum of these 16 terms is equal to the first term times 1 minus the rate to the n, so it's the 16th power in this case, over 1 minus the rate. So we are going to get an interesting number here. So I like to do kind of each piece step by step. So I'm going to say 1 minus 3 to the 16th power. Okay, that's a very small number. But I'm going to divide that by 1 minus 3. I'm going to divide that by negative 2. Okay. And then the last thing I want to do is multiply it by 4. So I get negative 1.999954. Or negative 1.99 repeating. Or as a fraction. It doesn't change to a fraction. Alright, well that's what we get. We should change to a fraction, but that's okay. Alright, so let's do another one. So we have 4 3/2 to the I minus 1. So this is my first term. A sub 1 is my first term. This is my rate. And I'm just going to plug in, this is my n. So I'm going to say S sub 6 is equal to the first term, which is 4, times 1 minus the rate, 3/2, to the n, over 1 minus 3/2. Alright, so 1 minus 3/2 to the 6th power. So 3/2 is the same as 1.5. So I'm going to do 1 minus 1.5 to the 6th power. Okay, so we get this number. And then I'm going to divide that by 1 minus 1.5. Okay, so I get 20 and change. And then I'm going to finally multiply that by 4. And this number, when I do it, I get 83.125. Okay, so the last problems I'm going to have you guys do are these two on the bottom here, and I will give you the answer you should get. This sum should equal negative 510 And this sum should be 5,115. Now, we want you to use the formula. We don't want you just to follow the rule and add it up, kind of like what we did on the first day of this unit. The idea is that you guys can use these formulas and use them to kind of see what you get. And hopefully that's, that works out for what you need. So that's all we got for you. Actually, hold on one moment. I think I have an error here. Something happened, and I want to fix it before we go forward. I knew this didn't look right. Alright, so let me try this top one again. Something happened when I was going through it. So 1 minus 3 to the 16th power. Yeah, I definitely did not get that number the first time. So, let's ignore this for a second. Okay. So I get this large number. This should be a very big number. I knew something was not right. So I'm going to divide this by 1 minus 3. I'm going to divide this by negative 2, which is what I did here, and then multiply that by 4. Yes, that is much, much, much better. So 860934440. So sometimes even I have calculator plug-in issues, but that is what we should get. Top, then divide it by the bottom, and then multiply it by the number in front. And that is all I have for you guys today. Alright, so thank you guys for watching.